Hello friends. So in this video I am going to discuss this question. This is a geometry question, and the question says, in the figure given below, PT bisects the segment SQ. Okay, segment SQ also happens to be the chord, and if PT is bisecting it, so I know for a fact that PT somewhere is passing through the circle center. Exactly where is the center I have no idea as of now, but let's see. And a tangent to the circle touches the circle at P. So this tangent is touching it at P, fine. And PQ makes an angle 60 degree. PQ makes an angle 60 degree with the tangent if the angle TQR is 30 degree. Okay, if angle TQR is 30 degree, what fraction of the area of the full circle is the area of the triangle? So area of triangle TQR is to area of the circle. Okay, so this is what they have asked. So basically they're asking you to find out the ratio. Let's see if I can do something with it. The very first thing that comes into my mind is 2, because there is a tangent and there is a chord. I know that alternate segment theorem will come into the picture, and if I do this, if I add PS, I know this is also 60 degrees. So this is alternate segment theorem. Alternate segment theorem says that if there is a circle and the circle has a tangent and the chord, or this this thing, secant, making an angle theta, to the chord when make the chord is made another, the chord which makes an angle in the alternate segment. So right now the chord, this chord, let's say which chord, AB, this chord AB, and this line, let's say L. So this chord AB is sitting in the minor segment. So this chord, when it makes an angle in the alternate segment, this is a major segment, this will be equal to theta. So these two angles will be equal. So this is alternate segment theorem. Okay. So let's see what else can I do with it. I am just discussing this theorem or this property just for the sake of simplicity and the students who have not studied the property so far. So this is 60 degree. Okay. And also I know that this has to be 90 degree. So what else do I know? If I add this line and I add this line, if this is 90 and this entire angle is 60, so this has to be 30, this part has to be 30 degree. Similarly, this angle and this will also be 30 degree. This will also be 30 degree. So this will be 60, this will be 60. So this angle QOS will be 120 degrees. Okay, which will eventually make this angle to be 60. And yeah, so basically a lot of things I have been able to calculate from this thing. Now if I look into this triangle OQR, so OQR, or I can say OQT, triangle OQT, and triangle TQR, a lot of similarities there. This is 30 degree, this is 60 degree, this is also 60 degrees, this is 90 degree, of course. So I know that these two triangles are similar. Okay, now can this be that simple? So let's say I am drawing this triangle TQR. Okay, so I'm drawing this triangle TQR. So TQR. Now please understand this is TQR. Okay. I made a mistake. Okay. The mistake is that I made the triangle a little mistakenly. So it's actually going to be something like this. Okay. So it's actually going to be something like this. Okay, so T Q R. This is 90, this is 30, and this one is 60. Okay, which means that the side opposite to 30 will be x, opposite to 60 will be root 3x, and this will be 2x. Now please remember, this is a special triangles, 30, 60, 90 triangles, okay, which says that this is the ratio of the sides. If the angles of a triangle are in the ratios 30, 60, 90, this will be 1 is to root 3 is to 2. Okay, this is special triangle. You can also arrive at this through Pythagoras theorem. Now the reason I know that TQ is equal to TQ for both the triangles TQR and OTQ also, so somewhere this thing happened. So I know for a fact that these two triangles are congruent. They're not looking congruent, but I know that these two triangles are congruent. Okay, because all the angles are equal and the hypotenuse is also, or not the hypotenuse, but one of the sides has come out to be like this. Okay, so root 3x. So what can I do with it? So the area of the triangle, so the agenda was to calculate area of the triangle TQR. So the area of the triangle will be half into base into height, which is root over 3x, into height is x, okay, by area of the circle. Area of the circle. Now please understand that this is the circle, or this is the radius of the circle, okay, which is pi r square. So pi into r square. Now please pay attention. This is also a 30, 60, 90 triangle in which one of the sides 60 के opposite वाला is root 3x. Similarly, this is 30 degrees. So opposite to this will be 1 or x. So which is, this length is 2x. Okay. So we didn't have to do anything. It's just the special properties of the triangle that is giving me everything. So 2x ka whole square. Okay. So this is going to be, this you can send to the denominator. So you can probably write root over 3x square. Let me see if my video is cutting anything. No. So root over 3x square by 2 ka square is 4 times this 2 is 8x square and a pi. Okay, so this x square cancels. So ultimately the answer is root over 3 by 8 pi. This is your answer, root over 3 by 8 pi. Okay, so a good question. I mean, I hope you enjoyed it. If you did, you know the drill. Like, share, subscribe, and share it with your friends, guys. Please remember, I grow with your support. Okay, so if only you guys support me, I'll be able to grow. And see, agenda is to make sure that everybody is comfortable with all these type of questions. Okay, please remember, this is a mock, previous mock question, so a pretty quality question which can definitely come in your exam. Okay, this is how I would have solved it. If you would have solved it any other ways, that's great. Kudos to you. Chalo.